Thank you.
All right, let's actually get the steps out of the way first for finding second derivative, and then we can just look at examples. So if you want to just draw a box somewhere to the left, these are the guidelines for how to find second derivative. First, you just find the first derivative. So you're given a function, you find the first derivative. Then you use that to find the second derivative. So basically, you're going to find the first derivative, then you're going to take the derivative of that and find the second derivative. Then here's the important step. Once you find that second derivative, it's going to have a y1 in it somewhere. And we are going to plug in what we found for y1, because technically this is y1, right? And then this is going to be y2. So we're going to plug in what we had for y prime, what we found originally. You're going to plug your y prime into where it belongs in your second derivative. The examples will make that make sense. But like, you're going to find the first derivative, then we're going to find the second. But somewhere in the second, there's going to be a piece that says y prime, and we're going to be able to plug in what we found into that slot.
Plug that into y2?
Yes. So our y to the second, y double prime, will have a y prime in it somewhere.
Yeah.
And so all we're going to do is we're going to take what we found for y prime up here and plug it into that one.
So
Yep.
y prime.
Plug y prime into where it belongs in the y double prime. And then step 4, and almost always your final step in math, just simplify. Okay? So here's our first example, and I want you to recognize how it's written too, because this is the only thing it will say. It'll give you a function like this, and then it will tell you to find d squared y over dx squared. This is the symbol for second derivative.
That's 25 or 2.
Huh? That's a 25, sorry. My 5s look like S's.
I didn't know if you wanted like a variable added to.
Yeah, no, that's
Why
fine.
is the order of the squared multiples?
Because it's just normally d dx, and so they're just showing you, like, this is the basic one. So they're just putting the 2, it's just like the second derivative. It is kind of weird. You're like, why is it before the y? And then, yeah. So let's follow our steps. Let's find our first derivative. What's the derivative of x squared with respect to x? 2x. Derivative of y squared? 2y, y prime. Derivative of 25? 0. So not bad. Let's isolate our y prime here. So we're going to have y prime equals negative 2x over 2y once you've moved it and divided, which then is just negative x over y. So first step in the bag, we found the first derivative. But now we're going to use this to find our second derivative, and then here's the catch. What rule are we going to have to use to find the derivative of this? Quotient rule. Make sure you notice that. Derivative of the first times the second, so just negative y, Riley, minus the first times the derivative of the second, all over the denominator squared. So let me just clean this up, and this is our second derivative here. Second derivative is negative y plus xy prime over y squared. Step 2 complete. We found the second derivative. But what do we have to do now with this y prime? We technically already found y prime, so we are going to insert that into that slot, and then we're going to kind of simplify it out. So you find the first derivative, you find the second, But in the second derivative, there's going to be a spot where y prime is, and since we've already found y prime, we're able to insert that in. Nick?
So second derivative is just the derivative of.
Second derivative is just a derivative of the derivative, but to find that, we want to then plug in our first derivative into its spot to get like a final answer.
Got it.
It's like Inception. We're just going layers deeper, right?
Yeah.
While we're there, I'll plant a seed so that you make a final 100 on the final exam. Okay. So let's rewrite this. Take a look. I'm going to just rewrite this, and you tell me if this makes sense. Like, do you see what I just did? That should have a minus sign, a plus sign, by the way. Like, you just kind of put it where it belongs. You can use parentheses to group it off. I'm going to slide this up a little bit to give myself more room. And now from here on out, literally we're doing nothing else except for simplifying. So like there's going to be 3 or more steps, but I don't want you to think I'm pulling this out of thin air. I'm just trying to simplify this. So I have this, negative y plus, it's actually x squared over y.
Would it be negative?
It would be, yeah. So that sign should be a negative, so I'll just keep this there for now. Riley?
On the top equation under the red circle,
Yes.
So you can have like a y and a y prime in the same equation. Like why are both of them not y prime?
You can, because when we did our quotient rule here, we did derivative of the first, which was this, times just the second. And that second was y. But then over here, we did the first times the derivative of the second, and the derivative of y gave us the y prime. Does that make sense?
Yeah.
It only becomes y prime if you're taking the derivative of a y term. Okay? So then here, I'm going to tell you what my last step is, and then you can just see it done. I need to combine these using least common denominator, and then rewrite my fraction, which is very easy. There's a y on bottom. We need to multiply this by y over y. So we'll actually have negative y squared minus x squared over y squared. Least common denominator on the top. Multiply this by y over y, and it merged into one fraction there. This became y squared over y minus x squared over y, so they join together. That's why you do your least common denominator there. And then we have one step to go, because we don't like these fractions on fractions. Let's put our final answer as, you know, anytime you have a fraction over just one term, basically this is just going to shoot to the denominator. So you're going to have negative y squared minus x squared over y to the third. I was talking to Miss Napier about this, and she agreed. It's never the calculus that gets anybody, it's the algebra. Like, you guys can almost do derivatives now in your sleep. Like, you got those shortcuts, you know them. But it's the fact, how did you get from here to here? And that's not even calculus, that's just algebra. But you got to really pay attention to kind of make sure your algebra stays sharp. Yes?
Why is it y cubed on the bottom?
Because since it's, technically this is y squared over 1, right? So the way we've done it in pre-cal is like the top times the bottom,
Oh.
and then the middle times the middle. I just took a little shortcut. If you ever have one fraction over just one little term, whatever's in the denominator up there is just going to be multiplied on the bottom. Okay? So I want you to try one more example, and then we're getting close to our 15 minutes for this. So I want you to try, what problem? This one. Try that guy there. X squared plus y squared equals 36.
It's just gonna be the same thing, isn't it? It's just,
Yeah.
you only change the constant on the right, and it's just gonna be
Zero
zero.
turn into zero.
Yeah.
What do you mean?
It's the same as the example we just did. Just a different
Yeah, that's
number.
fair. Let's try something else.
Let's do that one. 36.
Let's do this.
Yeah, if I go with that.
I'll be nice.
You were.
I'm beyond the moment where I can make up problems at work. I'm out of my league there. I can make up pre-cal problems, but it's hard to make up calculus problems. Sixth period, before you turn this video off, go to calcchat.com and find the answer to this problem worked out. Okay?